Hello, everyone. Welcome back to another AWS Cloud Computing um, class. We're going to be doing cloud computing once again this week. So let me share my screen and then we can get started again. All right. So once again, welcome to cloud computing. Let's start off with talking about what cloud computing actually is. So, the definition is the on demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay as you go pricing. So, AWS, Amazon Web Services, started cloud computing in 2006, where they had started to sell IT infrastructure services to businesses as websites. And this provides a simple way to access servers, storage, databases, and a broad set of application services over the internet. A cloud services platform like AWS owns and maintains the network connected hardware which is required for these services, while you provision and use what you need to use. Cloud computing helps to build and run applications, and it can also be used for the deployment and management of applications. It's available to hundreds of thousands of customers across 190 countries. It's powerful resources at a low operational cost. And the classically provisioning services is like a Goldilocks problem. But with the help of AWS, you're able to elastically scale both up and down as you need to. So let's talk about some cloud benefits. One benefit is the ability to deliver innovative new features to the market quicker. With the cloud, you can focus on adding differentiated value and you can make new ideas feasible that were at one point out of reach. Here, experimentation becomes fast and has a low risk. You can adjust to fit any workload and you can help businesses serve their customers globally without the need for expensive time consuming expansion. With the cloud, you can deploy web services using tools and languages such as Chef, Visual Studio, PHP, Java, Python, etc. And you can also connect to personal infrastructure by a private and dedicated connectivity. Now let's continue on the benefits. There are six benefits on the slide. One of them is trading capital expenses for variable expense. The other is benefiting from massive economies of scale. There's stopping guessing about capacity, increasing your speed and agility. Stop spending your money on running and maintaining data centers, and being able to go global in minutes. So for the first one, which is trading capital expense for variable expense, you get to pay for what you consume, and get to pay only when you're consuming it. For the benefit from massive economies of scale, you are offered a lower variable cost, and you're able to achieve higher economies of scale. This is going to help you with lower prices, and with this, you can stop guessing about the capacity. You can access as much or as little as you need, and you can scale up or down when necessary with a few minutes' notice. You can also increase your speed and agility, so you can reduce the time it takes to make resources available, and it causes a large increase in agility because of the cost and the time that is used to experiment being extraordinarily lower. You can also stop spending money on running and maintaining your data centers. So this just means focusing on your own customers and also going global in minutes. So you can deploy your application in multiple regions around the world extremely quickly in just a few simple steps. So this basically means that you can just provide lower latency or delay before transfer of data and a better experience for your customers at a small cost. Now for the total cost of ownership or the TCO. So the total cost of ownership basically reduces the need to invest in large capital decisions. It provides, once again, a pay as you go model that allows you to invest in the capacity you need and use. TCO calculators allow you to estimate the cost and savings, and the calculators also modify the assumptions that best meet your business needs. This calculator provides directional guidance on the possible savings that you could have, and the tool itself is built on an underlying calculation model. It generates a fair assessment of value that a customer may achieve. And it's important to note here that the TCO calculator results should only be used as an approximation. So once again, for all of our slideshows, the videos that are in the slideshows are going to be posted in the description of this live stream that you are watching right after it's ended. So if you'd like to learn more on each of the topics, you can watch these videos. All right, day two, types of cloud computing. So there are several different models of cloud computing, and these models all allow different amount of control over web services. There are three main types. Number one is infrastructure as a service, or IaaS. Number two is platform as a service, or PaaS. And software as a service is number three, and it's also called SaaS. To go into more detail on each of them, let's start on infrastructure as a service. So this one contains the basic building blocks for cloud IT, and it typically provides you access to networking features, computers, and data storage space. It has the highest level of both flexibility and management, and it's most similar to existing IT resources. It also offers instant computing infrastructure. Now for platform as a service, or PaaS. So this one removes the need for organizations to manage the underlying infrastructure. So this is usually just hardware and operating systems. It allows for the focus on the deployment and management of applications, and it also helps for business owners to be more efficient. It also ends up disregarding human concern over resource procurement, capacity planning, software maintenance, patching, etc. And PaaS is also a combination of both hardware and software components. Now for software as a service, or SaaS. So this provides customers with a completed product that is both ran and managed by the service provider. SaaS is usually referred to as end user applications, and there's usually no user concern about service maintenance or how infrastructure is actually managed. You only need to know how you are going to use the software. And an example of this is having a web based email to send and receive the email without having to manage feature additions. Another video that's going to be in the description. Okay, now to talk about day three, which starts off with how to actually deploy the cloud infrastructure easily. So there are four key areas that you want to keep in mind when deploying um, the cloud infrastructure to make it as easy as possible. Number one is the highly trusted global infrastructure. This is designed for high security and availability needs of the large enterprises. It offers capabilities that would restrict unauthorized access or usage without sacrificing flexibility, and it's ultimately a backup for all features. Number two is providing broad compatibility with all popular workloads. So here you can spin up virtual servers, hard drives, databases, networks, and more. And you can easily set up virtual servers using Linux or Windows. Number three is fast and secure private networking. So this is provision on a private section of the AWS cloud that's you define and you retain control of. It's done with simple IP networking, And at this point, cloud environment becomes an extension of your on-premise environment. It uses a standard pipe that encrypts data when it moves from your environment to the cloud, and more data creates a dedicated network connection from your existing data centers to AWS. It also gives you predictable network or a performance increase by bypassing the public internet. And there are certain tools that you could use to control access to all of the cloud resources. You can create and manage users and integrate with your existing identity systems. And you can also give greater flexibility to rapidly create new apps, lower costs for existing apps, and benefit from the global infrastructure and the security of AWS. Now to talk more about the cloud itself. So the cloud-based applications are fully deployed in the cloud, and applications in the cloud are actually created within the cloud. Either this or they're migrated from an existing infrastructure in order to take advantage of the benefits that are provided. Cloud based applications can be built on low level infrastructure, and they can also use higher services that provide detachment from management, architecting, and scaling goals. Now, talking about hybrid. So, this is a way to connect infrastructure and applications. It connects cloud based resources and existing resources. A common method of hybrid deployment is to extend and grow an organization's infrastructure into the cloud while actually connecting the cloud resources to the internal system. Sorry. You can also run applications in both the cloud or on premise. And using the hybrid, you're able to access AWS whenever you need to. Now for on premise. So on premise is usually referred to as the private cloud, and it uses the virtualization and resource management tools. On premise deployment leads to the inability to receive cloud computing benefits, and it's used to provide dedicated resources. Typically, it's the same as the previous IT infrastructure, but it also uses application management and virtualization technologies in order to attempt to increase the resource usage. Another video that's going to be in the description once this live stream has ended. Okay. Day 4 starts off with discussing AWS security. So AWS infrastructure installs safeguards in order to protect privacy. Data is kept in highly secure data centers, and it manages dozens of compliance programs. Segments of this compliance have already been completed, and it has the highest security without the user actually managing their own facility. It saves money at the same time. You can scale your security with your AWS cloud usage, and the security maintains regardless of the cloud size. Another video. AWS Analytics Services. So these services are a set of services that are used in order to handle every step of the analytics process. These services are powerful, flexible, but yet simple to use, and they ultimately enable organizations to put their unorganized data to work efficiently. Example services include the following: Elasticsearch. This is an open source search and analytics engine which is used to log analytics, real time application monitoring, and also user click analytics. Amazon Kinesis enables you to absorb, buffer, and even process streaming data to find insights promptly. Amazon Redshift can ask questions and combine exabytes of organized and disorganized data across your data warehouse, operational database, and data lake. using a language called Standard Query Language, or SQL. Amazon Athena is an interactive question service, which makes it simple to analyze data in Amazon Edge 3 using SQL. AWS Compute Services. So, AWS offers multiple services that can deploy, run, and also scale applications as virtual servers, containers, or code. Examples of this include Amazon EC2, which obtains servers quickly and inexpensively, Amazon Lightsail, which creates a virtual private server or VPS on AWS, Amazon Elastic Container Service, which runs in Docker containers, which basically just contains software that are in standardized units known as containers. And these containers package everything a software needs to run, including libraries, system tools, code, and runtime. AWS Database Services. So these are necessary databases for applications such as managed relational, non-relational, data warehouse, in-memory data store, and graph databases. Amazon DynamoDB is a fast and flexible database service for any workload. Here you only pay for what you utilize, similar to what we talked about before. The key value database that delivers nearly instantaneous single digit performance at any scale is this one. It's built to handle internet applications, and it's a fully managed service. It handles more than 1 trillion requests per day. RDS, or Relational Database Service, um, is a service with 6 well known database engines. It can be set up, operated, and scaled in just a few steps. All right, on to our final part of the presentation, day 5, which discusses AWS developer tools. So, AWS developer tools contain code and they automatically create, evaluate, and deploy applications. They're a set of services that both quickly and carefully deliver software. These services store and hold control to your application's source code. They're used for constant integration, continuous delivery, infrastructure as code, and monitoring. AWS Code Pipeline can create an end-to-end software release workflow using services. It's continuous delivery service that automates the release of pipelines in order to have fast and reliable application as well as infrastructure updates. It also effectively and efficiently delivers features and updates. AWS Cloud Development Kit is an open software development structure which is used to define your cloud application resources using known programming languages. It supplies cloud applications, and it can be a challenging process that requires you to perform manual actions, write custom scripts, maintain templates, or even learn domain specific languages. AWS CDK utilizes the familiarity and expressive power of programming languages in order to model your applications. And finally, AWS Code Deploy, which is a tool that installs applications and updates servers. It lowers the workload on developers and quickens the release of new products and features. Code Deploy makes it simple for users to rapidly release new features, help dodge downtime during application development, and also deal with the complexity of updating applications. The positives of Code Deploy include automated deployments, minimized downtime, centralized control, and being easy to adapt. Adopt. I meant to say adopt. All right, AWS management tools. These allow you to provision, monitor, and set forth your cloud environment. Here, you can maintain stable control without restricting your developmental speed. AWS CloudWatch is a service which was built for developers, system operators, site reliability engineers, and IT managers. CloudWatch provides information and insights to monitor your applications, understand and respond to system wide performance changes, optimize resource utilization, and get an allied view of operational health. It gathers monitoring and operational data in the form of logs, metrics, and events, providing you with a linked view of AWS resources, applications, and services that run on AWS and on premises servers. AWS CloudFormation. This provides a common language to supply important assets in the cloud. Provisions can be automated to be sent over and over again, and they model infrastructure, excuse me, using a simple text file. The AWS Systems Manager allows for the full control of the structure of AWS, automates the tasks which are needed for smooth operations, helps to guarantee security and compliance, and also detects a problem quickly. AWS Networking and Content Delivery Services. These allow you to isolate your cloud infrastructure, scale request handling capacity, and also connect physical network to the private virtual network. The networking products would work together in order to meet the appropriate requirements. Elastic load balancing coordinates with Amazon Virtual Private Cloud, or again VPC, in order to give networking and security features. It distributes the application traffic among different services, and it handles the traffic in one or multiple availability zones or data centers. It also improves the scalability or adjustability of your applications. AWS storage services. So these are reliable, secure, and adjustable locations for your data. AWS itself offers a wide variety of cloud storage services to support both the application and archival compliance requirements. Archival requirements are the dates when things can be archived, and they're stored away and hard to get back. One can choose from different options to build the base of your cloud storage management solution. In AWS, the different types of storage services include object storage, file storage, block storage, backup, data transfer, and edge computing and storage. And another video. So that is all for cloud computing today. Thank you for joining me once again, and we will see you next week where we will cover something else.